Okay, we are entering into the second level of the rational functions sketches. Okay, so far you people have seen that how important this is to be aware of the vertical asymptotes, horizontal asymptotes, and then the turning points, and then the x and y intercepts. Okay, now all is going to be same with just one addition over here. That is the oblique asymptotes. This is something being added into your previous learning. If you look at this, this first part over here, previously there was just a number and then plus a fraction when you were dividing this improper fraction into a polynomial and a fraction. So look at this. This is a quadratic one in the numerator, and there is a linear denominator down here. So when you divide this, you get it something like this. This is 3x squared plus x plus 3, and that is x plus 1. So this is going to be 3x squared plus 3x. Okay, this cancel. This is minus 2x plus 3. So we have minus 2. So it's minus 2x plus minus 2. So so this is going to be 5. So this y, which was equal to this, that is now 3x minus 2 plus 5 over x plus 1. Now when this goes to 0, like when this x becomes very large, so all of this will be 0, so you will be left with y equal to 3x minus 2. So that will be your asymptote, and that is the oblique asymptote. Okay, so we have two asymptotes here. One is the oblique one, which is y equal to 3x minus 2, and then you have a vertical asymptote as well, which is going to be x equal to minus 1. Okay, now let's okay, I'll be sketching some upcoming questions. Let's just stick to the methods where we're learning how to find the oblique asymptotes and the any other asymptotes. Okay, so we had two asymptotes over here. Now please try this b part where you have y is equal to x squared plus 3x minus 31 over x minus 4. I know that the vertical asymptote is going to be, x equal to 4. Now please help me to find the corresponding oblique asymptote. Please find that. Okay, let me check if you are telling us the correct answer. This was like this, x minus 4, and I have x, first of all, this is x squared minus 4x. So we have 7x minus 31. So plus 7. So 7x minus 28. I change the signs. So I have minus 4 left, yes? So this is, let me change the color. This is not very prominently seen here. This is x plus 7, and then minus 4 over x minus 4. So this was already known that x equal to 4 is a vertical asymptote, and your oblique asymptote is going to be y equal to x plus 7. Okay. Now let's see if we have a question here where we have to sketch this.
Sir, it's 3 over x minus 4.
Oh, yes. Oh, I'm making so many mistakes here. So thank you for the answer. It's 3 over x minus 4. Thank you. Okay, so let's see if we have a question where we have to sketch such rational function. Okay, let's try this fourth question where we have to sketch this. So there will be an oblique asymptote. How do we know that there will be an oblique asymptote, by the way? Yes? Is there a way to figure out that there is going to be an oblique asymptote?
Quadratic hai upar.
Improper fraction, and there is a difference of 1 in their degrees. Okay, this is the linear one, this is the quadratic one. So linear into linear can give us a quadratic thing. Okay, so this is x squared plus 3. This one is x minus 2. This is x squared minus 2x. This. So this is 5x. Then we have plus 5. So 5x minus 10. Oh, I have this plus 3 here, so I have to bring it down here, okay? Oh, I'm making such a big mistake. Come on, this was 2x because this is 3. I just added, do you see that how silly mistake I'm making? So this is 2 over here. This is 2x and this one is 4, okay? Yes, I was doing this wrong. So this is, so you see, that is why we should not be keeping the unlike terms under each other. So if I had written it somewhere over here, I could have avoided making such a silly mistake. You got it, bacho? Yes? Come
Yes.
on. Yes, okay. So this is going to be x plus 2 plus 7 over x minus 2. So we have a vertical asymptote, which is going to be 2. We have an oblique asymptote, which is going to be y is equal to x plus 2. Now let's quickly find any turning points over here. For the turning points, I'll quickly be finding dy by dx. It's better to differentiate this over here. So I have 1 minus 7 over x minus 2 whole square. That is equal to 0. So x minus 2 whole square equal to 7. So we have two turning points over here. One is going to be, yes, this is x. Yeah, okay. So now tell me quickly, what are these turning points? So we have these, these are the x coordinates of the turning points. So you see that how quick you have to be on this differentiation, okay? Now, next thing is we have to see that if we have the intercepts, okay? For the intercepts, these are the asymptotes, okay? These are the asymptotes, and these are the x coordinates of the turning points of stationary points, okay? And now let's see if we have the we have those x intercepts. So for the x intercept, I'll be putting y equal to 0. Do I get any x intercept? No, there is no x intercept, okay? When I try to find the y-intercepts, okay, the y-intercept. So I'll be putting x equal to 0. When I put x equal to 0, I have y equal to minus 1.5. Yes. So we have these, yeah, minus 1. Bilkul theek hai. Okay. So this is the y-intercept, okay, and there is no x-intercept. Now let's prepare the grid for this sketch, okay. I have to show x equal to 2 over here. This is x equal to 2. That is my vertical asymptote. Okay. Then I have to show um, the oblique asymptote, y is equal to x plus 2. Okay. So this is my oblique asymptote. Can you see this, or should I change the color? Let me make it a bit darker. Again, you should be very quick at drawing these lines. Okay, this is 2, this is minus 2. Okay, so now we had the turning point at 4.65, This is 3, this is 4, this is 5. Oh, this will go somewhere over here. Now tell me quickly, let's have a table over here. This is X, this is Y. I take 3 over here. You have to tell me if it is positive or negative. And I take this 0 over here. Okay? Yes. Before and after this asymptote. So tell me, when I put 3 over here, 5, yeah, this is going to be positive. When I put 0 here, this is, yeah, this is going to be negative. This is positive, this is negative. Okay, so that means the curve is going to be, one turning point was over here. So it was to be, a curve would come from here, and here is the minimum value, and then it will go like this. Okay, and there the curve would be, the turning point is at minus point somewhere over here. Okay, and its y-intercept is at minus this. Okay, so this curve would be, is there any x-intercept over here? No. So this is going to be coming like this, this, and this. So that is how you will have these curves, Bacho. One is up here. I hope you can see that. One is over here. This one here. The other is over here. I should have taken a smaller scale. That could have been, yeah, I could have drawn that more easily and more reasonable curve. Okay?